Hello students. In this video, we'll learn about the sequential pattern mining. What is a sequence? A set of ordered events, we call it as a sequence. For example, we have here E1 to E5 elements which are placed in a set and it is called what? A sequence. Then what is the sequential pattern mining? Finding the frequent subsequences from the set of sequence, we call it as a sequential pattern mining. From this, we can have the set of subsequences as E1, E2, E3, E4, E4, E5, and all, right? These are called what? Frequent subsequences. And all these frequent subsequences are represented with the angular braces. Then what is the difference between the transactional databases and this sequential databases? The transaction database consists of transaction ID and along with the item sets. The items in the transaction can be placed in any order. In the sequential database, the elements are placed in an order. Now, what is sequential pattern mining? Just like the transactional database, here also we will have the minimum support threshold and the frequency count of each element is compared with the minimum support threshold. And if that count is greater than or equal to minimum support, then only those elements are considered as a frequent subsequences. Here, to know about the frequent subsequence, just consider this sequence where it has an elements A, ABC, AC, DC, F. So these items are placed in this order. Now, when you look at that, you can see some of the elements are placed in brackets and some of the elements are placed without the brackets. So if any element is placed within the brackets, it means that they come under the same sequence. If it is represented without the braces, it means that the A can be in one sequence and B can be in the another sequence. So let us understand this with an example. I just want to find out AB of C, whether it is a frequent subsequence of given database or not. So for that, first initially I have to check for AB, then I have to check for C. When you look at this, AB belongs to same transaction or sorry, same sequence and C should be in the different sequence. Now look at the first sequence. We can find AB in the one sequence and C in the another sequence. Now the support count starts here and now the support count will be what? 1. When you look at the second sequence, there is no AB here. When you look at the third sequence, we have AB in the same sequence and C in the different sequence. Now the support count will be increased and it will be what? 2. And in the fourth sequence, we don't have AB, right? So now the support count value is what? 2. And this support count value is compared with the minimum support count. And it is satisfying the condition, it should be greater than or equal to the minimum support count, right? So we can say that this AB of C is a frequent subsequence. In the similar way, if I want to find out EG in the database, EG, E can be in the different sequence and G can be in the different sequence. Now, let us look at the first sequence. We don't have any EG here. In the second sequence, we have E, but there is no items after the E. And here in the third sequence, we have E, but there is no G, right? Here we have EG and the support count here is what? 1. It is less than the minimum support count. So we'll eliminate this sequence. In this way, we can find all the frequent subsequences that are there, right? So let us understand clearly this with the different algorithms. So sequential pattern mining has different algorithms and among those generalized sequential pattern mining is also the one. Initially in this GSP, first the database is scanned for the candidate of length 1. And after finding the length 1 candidates, then it is repeated for the k plus 1 sequences. So before this, after finding the length, we need to find the support count. If it is satisfying the support count, then those sequences are considered, or else the other sequences will be pruned, just like the a priori property which we have seen in the earlier videos. And we will just follow the steps until there is no frequent sequence or no candidate which is found. So let us understand this with an example. Here we have the sequences and its ID, right? As I told you, if any sequence is represented within the braces, it should be in the same sequence, or else we'll represent that in the different sequence. Here the minimum support is given as what? 2. And now we need to find the one length sequence. So for that, initially identify what are the different elements which are there in the sequence database. Okay, so we have here elements from A to G, and after that we need to find the frequency or the support count of each element. So here if I want to find the support count of A, In the sequence 1, A is repeated 1, 2, 3. So the support count is what? 3. If you want to find for the support count of B, 1, 2, 3, 4, right? So it is repeated for 4 times. In the same way, we need to find for the other elements. And now we need to compare this with the minimum support count. When we look at this one line sequence support, all the elements were satisfying except the D, because it is having the less than the minimum support count. So this element will be pruned. And after this, we need to join the L1 with L1. And to do this, here we'll have two cases where we, if X and Y are the two elements, X will be in the different sequence and Y will be in the different sequence. And here, if they are mentioned in the same, within the braces, it means that they'll be in the same sequence. Let us see that. So this is the one line sequence after eliminating the element which is having the less minimum support. And then we need to create the two length sequence. So to create the two length sequence, we need to create the two length sequence for every element which is present. So now let us start with A. So we are finding two length sequence of A. So A is now compared with B. So AB, AC, AE, AF, AG. And then we have to create two sequences, right? One with the different transactions and one with the same transaction. So if they are there in the same between the braces, it means that they are in the same transaction. Now, how to find the support count of this? So here initially we have A, B, right? So it means that A can be in one transaction and B can be in the other transaction, right? So here A is in one transaction and we don't have B here. And here A is in one transaction, B is in one transaction. So support count, so it is sequence actually. So it is what? Support count is what? 1. So here A is in one sequence and B is in one sequence. So the support count is what? 1 plus 1, 2. So the total support count for A, B is what? 2, right? So here, and the minimum support count given is what? 2. And it is satisfying the condition that it should be greater than or equal to 2. So we can say that AB as a frequent subsequence. Similarly, if you want to find out for A comma B. So A comma B, they are there in the braces. It means that they should find in the same sequence. So here we can see A comma B in the same sequence. And when you look at the whole database, we can see here the A comma B in the same database, right? So now the count of this A comma B will be what? 2. So this also is satisfying the minimum support threshold. So this A comma B also can be considered the frequent subsequence. So here all the elements A, F, E, A, G, all these two length sequence are considered to be frequent subsequence except this A comma C, A comma E, A comma F, A comma G. All these are not satisfying the minimum support threshold. So all these elements will be eliminated and then we'll create this sequence for the two length sequence. This is created only for A. Now we need to create for the other element B, C, E and all. So let us see that. And here, whatever is there, if we have A, B, it means that A is in one sequence and B is in one sequence. If you are writing BA, B will come first, then A will be the next order, right? When it is AB, A will be the first order and B will the next order. So these are not equal. But when you are saying representing that in the braces, they will come to same. They will be in the same sequence. So it means that A comma B or B comma A, it both are equal. And now, so finally, the one length sequence is this, which is obtained. Next, for two length sequence for A, similarly, you need to find out for B. As I told you, A comma B is not equal to the B comma A. Here, B, A will be the next sequence. Next, B, C, B, E, B, F, B, G. But we did not find B comma A. Why? Already A comma B is present in the two length sequence of A. So if they are present in the same sequence, there is no need to write it again or it will not be repeated, right? So in the same way, we'll create for the two length sequence of C, E, F and G, all the elements. So whatever the elements which are present in the brackets, those elements will not be repeated. Now we need to find the frequency or the support count of each items which are present here. For example, here we have CB. When it is C and B, or it means that what they should be in the different transactions, right? So now I just want to find out whether what is the support count of CB, right? So to do that, I need to find out for CB. So it is not in the braces, means C should be in one transaction, one sequence, and B should be in the other sequence, right? So now let us find C is here. We can find B in this sequence, but it is not in the order. So we'll not consider this. And look at the next sequence. We have C here and B here. The support count starts and the support count will be what? 1. So we don't have any C here and we don't have any C here. So the support count is what? 1. Now we'll have the support count as 1. Similarly, if you want to find for CE, so C should be in one sequence and E should be in one sequence. So here C is in one sequence, E is in one sequence. So the support count will be 1. And here also C is in one sequence, E is in one sequence. So the support count will be what? 2. So in the other, the third and fourth sequence, we don't find that E. So the support count is 2 and it is satisfying the condition. So we can take this as a frequent subsequence. So if you want to find for C comma E, so C comma E, they should be in the same sequence. So just let us find out whether they are in the same sequence. We can see all the sequences in the, if we scan whole database, we can find we did not find any C comma E here. So the support count of the C comma E will be what? 0. In this way, we need to find out for all the frequent elements that we have, two-length sequences that we have, and whichever is not satisfying the minimum support rule, all those were eliminated, and which are satisfying the rule that are used to join for the to create the third length sequence. So now let us see how to create the third length sequence. So to do that, we'll be taking the contiguous subsequences to create the new candidate sequence. What does it mean is, so finally, after satisfying the support count, we got the two-length sequence as this. Now we need to create the three-length sequences. And to do that, first let us consider first two elements, AB and AC. When you take the two elements AB and AC, according to the sequential pattern mining, first we need to check for first element of this sequence and the last element of the sequence. So here, when you remove this first element and the last element, the middle element should be the same, right? Here we don't have the same elements. It means that they cannot form the frequent subsequence. Here we have AB and BE. So if you remove A and E, we can see these are the same elements, right? So it means that ABE can form the frequent subsequence. Similarly, for A comma B, B comma E, if A and E is removed, we have the same B here, right? But the thing is, A comma B should be in the same sequence. When you are generating the rule also, when you are generating this third line sequence also, it should be in the same, right? Wherever we have the so same sequences, that should be considered. So in the next example, if B and G is removed, we can see that it forms the subsequence. But here F and G should be in the same sequence. So that should be clearly mentioned, right? Now, after finding this, now we need to check in the database whether these transactions or the occurrence of these transactions and they are satisfying the minimum support count condition or not. So here in the database, you can see that ABE. ABE means what here? A should be in the one transaction, B should be in one transaction, and E should be in one transaction, right? So let us see here. In the first sequence, it is not possible. AB is in the same sequence, so we will not consider that. In the second sequence, A is in 1, B, E. So the support count will be 1. Next, in the sequence, A, 1, B is there and E is there. So the support count will be what? 2. So now whatever we need to find out for all the third line sequences that are available, and then we need to compare this with the minimum support count. Next, we'll create the 4-line sequence. Just like the third line sequence, we'll compare this with the first and last element. If the remaining elements are same, then we'll consider that for the frequent subsequence, or else we'll not consider those elements for the frequent subsequence. And here in the 4-line sequence, if you look at this, if you try to compare with all the other elements, it is not satisfying. We can see that no middle elements are same. So it means that we cannot create the fifth length sequence. So we can stop our algorithm here. And so finally, we can say that these are the frequent subsequence which are formed from the given sequential database. Thank you.